Okay, topic 4, we're going to talk about more special quadrilaterals that are not parallelograms. They're called trapezoids and kites. Maybe you've heard of the trapezoid. But the idea with a trapezoid is that it's a quadrilateral with exactly one pair of parallel sides, in this case the top and the bottom, and they're called bases. So AB is parallel to CD, and those are the bases. And the non-parallel sides are called the legs, and they're not parallel to each other. So AD and BC are the legs, and then these angles that we have where the legs and bases meet are called base angles. So A and B are base angles on the top part of this, and angle C and angle D are the other base angles. So C and D are a pair of base angles, and A and B are a pair of base angles. A special trapezoid is called an isosceles trapezoid where the two legs are congruent. So PT would be congruent to QS, and that makes it the legs are congruent, so it's isosceles. And when we have that, we have a special condition where the base angles are going to be congruent. So angle P will be congruent to angle Q, and down at the bottom, angle S will be congruent to angle T. And finally, the last thing here you have, if you can see I did it in pink, the diagonals are going to be congruent. So PQ, oh, excuse me, not PQ, PS will be congruent to QP. They don't bisect each other like in the parallelograms, but the diagonals are congruent. Well, let's play the always, sometimes, never game. A trapezoid is never a parallelogram. It only has one pair of parallel sides. The bases of trapezoids are always parallel. The base angles of an isosceles trapezoids are always congruent. And the legs of the trapezoid are only sometimes. That's if it's an isosceles trapezoid, then they would be congruent. So let's take what we know about parallel sides and trapezoids and figure this out. So let's figure out the other angles. Well, if this is 53 degrees, and since it's an isosceles, the measure of angle B also has to be 53 degrees. And then we have, well, angle A and angle D have to be parallel. They have to add up to 180. So the measure of angle D is 127 because that adds up to 180 with 53, which is also equal to the measure of angle C. If we go to over here, A and D have to add up to 180 degrees. So the measure of angle D has to be 89 degrees. And the same thing, B and C have to add up to 180 degrees. So the measure of angle C is 48 degrees. And then finally, again, we have a isosceles. So the measure of angle B has to be 108 because it has to match angle A. And then A and D have to add up to 180 degrees. So the measure of angle D has to equal 72 degrees. And so does angle C. So I want to show that ABCD is a trapezoid, not a parallelogram, by only having one pair of opposite sides being parallel. That means I should show that their slopes are congruent. So looking at this by eyeballing it, I think AB and CD are parallel, so they should have the same slope. I'm going to show the work. So you can see I found the slope for segment AB and segment CD, and they both have slopes of -1, so they must be parallel. Now I have to show that side AD is not parallel to BC, because if those sides were parallel, then it would be a parallelogram. And I've shown the work here, and you can see that AD and BC do not have the same slope, so they are not parallel. Another vocab word we're going to work on is the mid-segment of a trapezoid. The mid-segment is a segment that connects the midpoints of each of the legs of the trapezoid. So E is the midpoint of AB, and F is the midpoint of CD. So EF, segment EF, is the mid-segment. And since A and D and B and C are parallel, EF runs in the middle, and it is still parallel. So EF parallel to AD, and EF is parallel to BC. And the actual length of that segment EF is equal to the average of the sum of the two other sides, or of the other two sides, or half of the sum. So EF is equal to 1/2 AD plus BC, or in words, the mid-segment equals half of one base plus the other base. So using that formula, x is going to equal half of 7 plus 14. That's 21. Half of 21 is 10.5. Using it over here, 11 as the mid-segment is going to equal half of x plus 8. If I multiply by 2, I get 22 equals x plus 8. X equals 14. And over here, it's going to be the same thing, that 13 is equal to half of x plus 24. And if I multiply by 2, 26 equals x plus 24. So x equals 2. So the next thing we have, that's a quadrilateral, that is not a parallelogram, is called a kite. It has two pairs of consecutive sides that are congruent, not opposite sides, but consecutive sides, such so that AB is equal to BC and AD is equal to CD. None of the opposite sides are congruent. It's kind of this diamond-looking shape. But one pair of opposite angles are congruent. So you can see over here, angle A and angle C are the same. Angle A is congruent to angle C, but not the other ones. Not angle B and angle D. They are not equal. If we look farther into the picture, we can see that when the diagonals are drawn, forms a nice 90-degree angle, so that side AC, or segment AC, is perpendicular to BD, and the diagonals bisect these angles. So this angle here and this angle here are congruent, these two here are congruent, these two here are congruent, and these two here are congruent. And I'll write them out. I'm going to call this point M. I'm going to show you that what angles are congruent. So I've shown how all these angles are congruent to each other, and finally, the one diagonal cuts the other diagonal in half. So in this case, AM is equal to CM, but not the other way around. BM is not equal to DM, just one. So I have this quadrilateral map, and I know that angle H and angle A are the same, so the measure of angle A has to be 118 degrees. And if I add up all three of these angles right here, that's 317. So the measure of angle T plus 317 equals 360, because a quadrilateral always adds up to 360. So the measure of angle T is equal to 43 degrees. Over here, I don't really have the same. I know that these two add up to 101 degrees. But I know this angle A and angle H have to be the same. So I know like 2 times the measure of angle A plus 101 is equal to 360. 2 times the measure of angle A is equal to 259. So the measure of angle A is equal to 129.5. This also is the measure of angle H because they have to be the same because that pair of opposite angles are congruent. So finally I want to find the perimeter of this kite west, and I know that this is a 90-degree angle. So I can use the Pythagorean theorem. I can use my little distance formula. It's equal to the square root of one side squared plus the other side squared. So EW, which is the same as ES, is equal to the square root of 3 squared plus 7 squared, which is the square root of 58. And TW, which is the same as TS, is equal to the square root of 3 squared plus 10 squared, which is the square root of 109. And my perimeter equal 2 times the square root of 58, because I have 2 of those sides, plus 2 times the square root of 109. I have 2 of those sides. If I round it to 2 decimal places, my perimeter will equal 36.11 when I put that all into my calculator. And finally, I have this big table of all these properties and all the shapes that we learned: parallelogram, rectangle, rhombus, square, kite, trapezoid, and isosceles trapezoid. And I'm going to put a red X in everything that is true for it. It has to always be true, not sometimes, always be true. So both pairs of opposite sides are parallel. Parallelogram, rectangle, rhombus, and square. Exactly one pair. That's only for a trapezoid, and obviously with isosceles trapezoid, diagonals are congruent. Well, that works for a rectangle, a square, and an isosceles trapezoid. Diagonals perpendicular, that would be a rhombus, a square, and a kite. Could be with an isosceles, but it's not always. Diagonals bisect each other. That's the first 4. Both pairs of opposite sides are congruent. That would be that one. Remember, in an isosceles trapezoid, the base angles are congruent. They're not opposite angles. Exactly one pair of opposite sides are congruent. That would be an isosceles trapezoid. All sides are congruent. That would be a rhombus and a square. Both pairs of opposite angles are congruent. Again, that's the first 4. Exactly one pair of opposite angles are congruent. That would be a kite. And all angles are congruent. That's only in a rectangle and in a square. So we have all these properties, and it applies to some and not to others. And in the bottom of this page, I have this big giant Venn diagram that we had earlier, but we added more things. Not only do we have quadrilaterals, but how we break up quadrilaterals into parallelograms, and things that aren't parallelograms, and so on and so forth.